Hello dear students, this is your Engineering Mathematics 3 lecture. Today we are going to discuss inverse Z transform. This is the topic from Unit 2. In previous lecture we have discussed Z transform. Now inverse Z transform. Now there are two methods to find the inverse Z transform. That first method is partial fraction method and second method is inversion integral method. Now the first method, partial fraction method. Now see what is partial fraction method. To apply partial fraction method, it is necessary that the degree of numerator is not greater than the degree of the denominator. This is the condition for the partial fraction. The necessary condition is that the degree of numerator is not greater than, it must be less than the degree of the denominator. In case this is not means if the degree of numerator is greater than the degree of denominator, then we carry out the actual division till the remainder satisfies the condition. In this case, we perform the actual division, and the formula for the actual division is f of z is equal to p of z plus q of z upon r of z. This is the formula. The expression q of z upon r of z is then considered for expressing it in partial fraction. Okay, this is the formula of the actual division. Let f of z satisfy the condition specified. Then we obtain partial fraction of f of z upon z and not that of f of z. You remember one thing, that after satisfying the specified condition, it means if the degree of numerator is less than the degree of denominator, then in that case we can perform the actual partial fraction method, and that method is, in that method we obtain the partial fraction of f of z upon z and not that of f of z. You remember this thing here. Now see the example of partial fraction method. Find inverse z transform of z square upon z minus half into z minus 1 by 3. If 1 by 3 is less than mod z is less than 1 by 2. This is the condition here for z. Now we are going to find here inverse Z transform, means this bracket term is nothing but the Z transform. Means Z transform, we always use the notation for Z transform f of Z, capital F of Z, and its value is Z square upon Z minus half into another bracket Z minus 1 by 3. This is the value of f of Z, it is given. Now we are going to find the inverse Z transform, means our aim is to find the sequence for the Z transform. Now here degree of denominator is 2. Because there are two factors. If we multiply these two factors, we have a quadratic expression here. Quadratic expression means its degree is 2 and numerator degree is also 2. So degree of numerator is not greater than the degree of denominator. So here we can perform the partial fraction method directly. Now we perform the partial fraction method perform the partial fraction method for f of z upon z and not for f of z. So you divide both the terms, both sides by z, so that we have the term f of z upon z is equal to. Now in RHS term, z square upon z. So one z get cancelled, and in numerator only one z is there. So the term in RHS is z upon z minus half into z minus 1 by 3. So this is the actual, this is the f of z upon z term. Now we are going to do the partial fraction here for this term. F of z upon z is equal to. Now to separate denominator two factors, we write the terms a upon z minus half plus b upon z minus 1 by 3. But we can separate these two terms by using partial fraction. You know the partial fraction method, how to separate two terms using partial fraction. We already studied it in 12th standard, so you can easily separate these two terms by using partial fraction. And the coefficient, the arbitrary constant for first term is 3 and the arbitrary constant for second term is -2. So these are the two separate terms using partial fraction method. F of z upon z is equal to 3 upon z minus half plus -2 upon z minus 1 by 3. And then after separating these two factors using partial fraction method, you again shift or transfer this z which is in denominator of LHS side to RHS side, so that you will get the next term f of z is equal to 3 into z upon z minus half minus 2 into z upon 1 by 3. Now these are the two separate terms. Now we can find its inverse z transform. Apply inverse z transform on both sides. So inverse z transform of f of z is equal to 3 constant. Inverse z transform of z upon z minus half minus 2 to inverse z transform of z upon z minus 1 by 3. Now the condition for z is here. The condition for z is here. 1 by 3 less than mod z less than 1 by 2. So depending on the condition 1 by 3 less than mod z less than 1 by 2. Now the inverse z transform of f of z is f of k. 3 constants, so as it is. Now what is the inverse z transform of z upon z minus half? Now see what is the condition for half. For half, the condition is mod z is less than half. Mod z is less than half, then in that case, the condition for k is k less than 0. And the z transform is z upon a minus z. So here take minus sign common so that you will get the term z upon 1 by 2 minus z. This 3 as it is. And so the inverse z transform of this term is by using the formula which we have discussed in z transform of some standard sequences. So it is minus in bracket 1 by 2 raised to k, and condition for k is k less than 0. Minus 2 as it is. Now what is the z transform of z minus 1 by 3? And the condition for 1 by 3 is 1 by 3 is less than mod z. 1 by 3 is less than mod z means mod z is greater than 1 by 3. And so the condition for k is k greater than or equal to 0, because when mod z is greater than mod a, condition for k is k greater than or equal to 0, and z transform is z upon z minus a. In place of a, here it is 1 by 3. So you can write the sequence 1 by 3 raised to k. So this is your answer here. Here minus, we can take minus sign common. So minus 3 into 1 by 2 raised to k minus 2 into 1 by 3 raised to k. First term k is to k less than 0. For second term k greater than or equal to 0. So this is the z transform, inverse z transform using partial fraction method. The second example is here. Find the inverse z transform of z upon z minus 1 by 4 into z minus 1 by 5. Mod z is greater than 1 by 4. Condition is given. So this inverse z transform of bracket term is nothing but the z transform. And we use the notation for z transform f of z. It is f of z is equal to z upon z minus 1 by 4 into z minus 1 by 5. Now we do the partial fraction of f of z upon z. Here, degree of numerator is 1 because the power of z is 1. Degree of denominator is 2 because if we do the multiplication of these two bracket terms, we have a quadratic expression and its degree is 2. So here degree of numerator is less than degree of denominator. So we can perform the partial fraction method. And we do the partial fraction of f of z upon z and not of f of z. So you shift this z of numerator in RHS, sorry, in LHS side, so that we have the term f of z upon z is equal to 1 upon z minus 1 by 4 into z minus 1 by 5. Now you separate these two terms, z minus 1 by 4 and z minus 1 by 5, using the partial fraction method. And the arbitrary constants for both the terms are different. For first one it is 20 and for second one it is minus 20. We know how to separate two factors, two terms using partial fraction. We have already studied it in 12th standard, the partial fraction method. Using that method, you can separate these two terms here. Now after finding these arbitrary constants a and b here, means 20 and minus 20, you will shift this z of denominator term in RHS so that you will get the term value of f of z. It is equal to 20 into z upon z minus 1 by 4 minus 20 into z upon z minus 1 by 5. Okay. And the condition for z is here. It is given, a single condition is given here. And it is mod z is greater than 1 by 4. It is mod z is greater than 1 by 4. So mod z is greater than 1 by 4 means mod z is greater than 1 by 5. If it is z is greater than 1 by 4, then definitely z is greater than 1 by 5. Now apply inverse z transform for this function on both sides. So inverse z transform of f of z is equal to 20 into inverse z transform of z upon z minus 1 by 4 minus 20 into inverse z transform of z upon z minus 1 by 5. So inverse z transform of f of z is f of a. Sequence is equal to 20. Z inverse z transform of z upon z minus 1 by 4. And z transform inverse z transform z upon z minus 1 by 4. When mod z is greater than mod a is a raised to k greater than or equal to 0. In place of a, there is 1 by 4, and in second term it is 1 by 5. The answer is equal to 20 into 1 by 4 raised to k minus 20 into 1 by 5 raised to k. Condition for k greater than or equal to 0, because for both the terms 1 by 4 and 1 by 5, mod z is greater than 1 by 4, mod z is greater than 1 by 5. So for both, the condition for k is k greater than or equal to 0. And this is the inverse z transform using partial fraction method. This is one of the examples. We try to solve this example using partial fraction method. So this topic is over here. This first method, partial fraction method, is over here to find the inverse z transform. Thank you.